in multi-output regression involves dividing the regression problem into a separate problem for each target variable to be predicted. The approach assumes that the output are independent of each other. In other words, the approach involves developing a separate regression model for each output value to be predicted. For example, if a multi-output regression problem requires the prediction of three values y1, y2, and y3 given an input x, then this could be partitioned into three single output regression problems. Like problem 1, given x, predict y1, problem 2, given x, predict y2, and problem 3, given x, predict y3. Some regression machine learning algorithms support multiple outputs directly. They are linear regression, k-neighbors, regressor, decision tree regressor, random forest regressor, and so on and so forth. Next, we have multi-step time series forecasting. May be considered a type of multiple output regression where a sequence of future values are predicted and each predicted value is dependent upon the prior values in the sequence. Here we are, the snippet. Here we can see we are calling sklearn.linear linear regression. Then we are feeding the linear regression with the data, and then we are making a prediction. The same we will do with the k-neighbors for multi-output regression. Here we have the k-neighbors regressor, then we fed x and y, and we are doing the prediction. So similarly, we can perform for all other algorithms, decision tree regressor, as shown out here. Now, try this whole thing using a wrapper approach to reduce the number of codes. This wrapper function is very useful for those models that doesn't support by default. Here we are calling from sklearn.multi-output import multi-output regressor. Then we are calling it svm import linear SVR, and here in the wrapper equals to multi-output regressor. Then we are giving the model, that is the linear SVR, and then wrapper.feed, we are just feeding the data, and here it is, we have our prediction. Last and not the least is the regressor chain. Regressor chain develops a sequence of dependent models to match the number of numerical values to be predicted. But hey, I forgot to mention you. Whenever you perform a time series solution, try not to use the train and test data. Try not to split the data into train and test data because they are not going to be in a sequential order. So there are built-in functions in the sklearn to separate the train and test data that maintains the sequence, okay, and the pattern for time series analysis or for the time series prediction. Because when you do the sklearn train and test data, it will randomize and it will split the data in a random order, which we don't want it for time series. We want to preserve the sequence. So there are special functions inside the sklearn to perform that. Or you can do it manually, just by using the n rows. You take it from 1 to 500, then again you do the model training on 1 to 500, and then you do the testing on 500, from 500 1 to 700, the row numbers. Okay, got my point? Now, last and not the least is the regressor chain. Regressor chain develops a sequence of dependent models to match the number of numerical values to be predicted. This approach is an extension of the multi-output method, except the models are organized into a chain. The prediction from the first model is taken as part of the input to the second model, and the process of output to input dependency repeats along with the chain of models. For example, if a problem required the prediction of three values y1, y2, and y3 given an input x, this could be partitioned into three dependent single output regression problems as follows. Problem 1, y hat 1 given x predict y. Problem 2, y hat 2 given x and y hat 1 predict y2. Now problem 3, given x, y hat 1, y hat 2 and predict y3. Okay, so here we are. We have the snippet, how to perform regression chain. So just like before, we are calling the regression chain out here, and we are putting the base model, that is the linear SVR. And that's it. And the rest you're already aware of, the evaluation procedure and the performance by using MAE, mean squares, and the standard deviation. So we have our commonly used methods, ways to perform multi-label classification, as well as regression modeling techniques. There are a couple of more techniques to perform multi-class, like output code, binary relevance, adapted algorithm, and ensemble approaches. Multi-label for deep learning, which we will look into the next article. So stay tuned.